Are you sleeping or something?
No, maybe. I was looking at the clouds. We got to get ready to teach that lesson on clouds today.
Oh yeah, clouds.
Yeah. So sometimes you can see things in them. I look over there. See, that one looks like a frog.
You know what? This is actually kind of cool. I think I see a fish. I think I see a fish up there.
That one looks kind of familiar.
Yeah, I don't know what that is either, but it looks so familiar. I can't put my finger on it.
Those clouds over the track look pretty menacing. Almost look like some kind of face or something.
You know, it kind of looks like Dr. Perkins.
Mr. Bingaman, Mrs. Ostrowski, shouldn't you be teaching?
Where were you?
I was getting ready
just
for the
preparing for a lesson.
class. I had to prepare our lesson.
To understand clouds, we first need to understand how water can phase change into different states of matter. Let's pretend you get a glass of water and add some ice cubes. This cools the water and the glass. So if we look up close, we can see the air around the glass of the room does contain a certain amount of water vapor. However, water vapor is transparent. Whoops! Why don't we make it so that you can see the water vapor for the lesson? That's better. Now let's just focus on one molecule of water vapor. When the water vapor molecules make contact with the cool glass, the thermal energy of the particle is transferred to the glass. This transfer of thermal energy causes the water vapor to phase change into liquid water. This process of phase changing from a gas to a liquid is called condensation. So, the layer of water on your glass is derived from the water vapor in the exterior environment. It's not from the inside of the glass itself. This is why people use coasters with their drinks. Eventually, if you leave the glass out long enough, the ice cubes will melt. Leave it out even longer and you will get another phase change. The water molecules are loosely held together with bonds. Some water molecules will gain enough energy to leave the glass by phase changing into water vapor and escaping into the air. The process of phase changing from a liquid to a gas is called evaporation. If more thermal energy is given to the water, this process happens faster. Also, this will happen faster if the humidity or the amount of water vapor in the air is low. This means a glass of water in a warm and dry environment will evaporate faster.
As we've talked about before, start with sunshine shining down on a grassy field. As the sun rays shine down onto the grassy field, it causes the ground to warm. This warm ground will cause the air above it to become warm and moist because some of the water in the ground will evaporate into the air. As that warm, moist air begins to rise because it is less dense than the air around it, it loses air pressure, just like as you climbed the stairs of South Middle School during the lab, found that the air pressure was less on it. As it gets into the upper atmosphere, it loses so much pressure, the air molecules have come farther and farther apart from each other, they can no longer hold on to the water vapor as a gas, and some of that water vapor begins to condense as little droplets that we see as clouds.
We can connect natural cloud formation to contrail clouds from airplanes. Planes burn fuel, and the exhaust from the water droplets contains water vapor. However, at high altitudes, the air pressure is so low, the water vapor condenses into liquid water droplets and even freezes into ice crystals that form clouds that follow the path of the plane.
When the warm, moist air rises and forms a cloud, at first it tends to form a cumulus cloud. This is the low, shallow, puffy clouds, and light passes through them, making their bottoms white. As the air continues to rise and more warm, moist air rises with it, it can begin to add height to the cloud. This makes the cloud taller and it also makes it darker on the bottom as less and less and less sunlight can get through. When it pushes up into the upper atmosphere, we form a cumulonimbus cloud. These are the tall puffy clouds that flatten out on top, and light cannot pass through them as easily, making the bottoms very dark. These are where severe weather is most likely to happen.
All right, did that all make sense? Does anyone have any questions? Yeah, what's your question?
Have you thought about making this a video lesson?
Oh yeah, that would have been actually a pretty good idea.